So, hi everyone, welcome back to the channel. Today we'll be discussing the problem named as check if the linked list is palindrome or not. I'll just wait for a couple of minutes for others to join and then we'll begin with the session today. So, meanwhile, all of the other people are joining, so I'll just tell you some stats about this problem. So, as you know, the problem name is check if the linked list is palindrome or not. So the problem level is easy. Accuracy for this problem is 39.25%. So it is pretty low considering that this was an easy problem. The submissions are 100k plus. So you can see that this is an important problem because a lot of people have solved it. So what you have to do in this problem is you have been given a singly linked list of n integers and your task is to check if the linked list is palindrome or not. So we'll just wait for a couple of minutes so that more people can join and then we can begin ahead with the session. So all those who have joined this session, and if my voice is audible to all of them, then please give a +1 in the chat so that I know that everything is working fine, and then I'll begin with the problem. Okay. So I'll just wait for one more minute for others to join so that nobody misses the problem statement, and then I'll begin. Apart from this, what I want to tell you is that this problem which is named as once again, let me write it again. So this problem which is named as check if linked list is palindrome or not. So this problem, if you talk about which companies that this problem has been asked, so this problem has been asked in a lot of companies like Adobe. Then it has also been asked in Microsoft. Then it has been asked in Amazon, Make My Trip, and Snapdeal. So you can see that this problem has been asked in a lot of companies and it is regularly asked in a lot of interviews. So if my voice is audible to all of you and everything is clear, then please give a +1 in the chat so that I can begin ahead with the problem. Shall I move ahead with the problem? You can comment down +1 so that I can begin with the problem. So the what does the problem say? The problem in the problem, it says that let us say that we have been given this linked list that is 1, 2 and 1. So you have to tell, let's suppose that I give you a linked list which is this, that is 1, 2 and 1. So you have to tell me that whether this linked list, this particular linked list is palindrome or not. So how will you check that it is palindrome or not? So from left to right for checking that if a particular thing is palindrome or not, the left to right traversal should be equal to the right to left traversal. Okay, how? So if you will move from left to right, so this will give me an order 1, 2 and 1. Similarly, if you move from right to left, so first of all you will get 1, then 2 and then again 1, right? So this is the left to right order for this particular string. So is this much part clear to all of you? If this much part is clear, then please okay, so by 2 pointer. Okay, Paramdeer, we'll discuss upon it once I'll move ahead with the question. So let us say that if the linked list given to us was nothing but 1, 2 and 3. Okay, if the linked list that was given to us was 1, 2 and 3. So will this linked list be palindrome or not? So hi John Wick and hi Paramdeer. So will this linked list that is 1, 2 and 3, will this linked list be palindrome? Can anyone tell me in the chat? So this linked list will not be palindrome because the left to right traversal, in the left to right traversal we are getting 1, 2 and 3. From the right to left traversal, that is when you trace from this side, so you will be getting 3, 2 and 1. So you can see that both these are not equal, the traversals are not equal, so that is why this will not be palindrome. Okay, once this part is done, so let us discuss some of the problems. If the linked list is palindrome, then you will be outputting 1, you will print 1 or you will return true. If it is not a palindrome, so in that case you will return 0 or you can say false, right? So this is what the problem says. So if the problem statement is clear to all of you, then please consider giving a +1 in the chat and like the video, so that I know that I can move ahead with the approach part, right? Shall I move ahead with the approach part for this question, like how we can approach this problem and what are the various ways through which we can approach? Shall I move ahead? If everything is clear up till now, shall I move ahead with the approach? Also, you can like the video so that it reaches as many people as possible. So let's suppose that I've been given a linked list. Let's suppose that linked list is nothing but 5, then 5 is connected to 6, then 6 is connected to 7, then 7 is connected to 7 again, then let's say 7 is connected to 6, and then 6 is connected to 5. So first of all of you tell me that whether this linked list that has been given to me, is this linked list palindrome or not? Is this linked list palindrome or not? Just tell me if this linked list 5, 6, 7, then 7, then 6 and 5, is this linked list palindrome or not? Yes, it is a palindrome, right? This linked list is palindrome. The reason is that if you see, so moving from left to right, if you see from left to right, okay, if you see from left to right, so the order is 5, 6, 7, 7, 6 and 5. If you see from right to left, so from right to left also 5, then 6, then 7, then again 7, then again 7, then again 6 and 5, right? So this both the orders you can see 5, 6, 7, 7, 7, 6 and 5, and 5, 6, 7, 7, 6 and 5. So both of them are same. So that is why you will say that this linked list that has been given to us is palindrome, right? So what are the ways to check this linked list? So first, the first way is that the approach one that I'll discuss is, let me just erase this part. So what is the approach, what are the various approach through which we can do this problem? So the first approach is that insert all the nodes of the linked list into a vector or a list in case of Java, and then check if the vector of the linked list palindrome or not. Okay, if the vector slash list is palindrome, okay, or not. Is this part clear to all of you? That what we can do is, for this question we can simply make an array. Let's say we can instantly insert all the nodes in a list or a vector in case of C++. In case of Java you can use a list. So we can insert this all the nodes in a array or in a single linear data structure, that is a vector or a list. So what we can do is, once we have inserted them, so we can check that whether this particular list or a vector is palindrome or not. That is pretty much easy, because we can use we can move one pointer here and we can put one pointer here, then we can check if these two are equal, then we will check for this one and this one, that is the next towards the left, and this one. After this we'll check for 7 and 7. So this is how we'll check, and if that is not the case, then in that case we'll print no. Okay, so is this much if this approach clear to all of you, that we can insert insert the given linked list into a vector or a list in case of Java. In case of C++ we can use a vector, and then we can check that whether that particular vector or a linked list is palindrome or not, right? This is very much easy and intuitive. So for this, the time complexity that will take is, the time that will take for this approach is order of n, and also the space that we will take for this approach is also order of n, right? Is this approach clear to all of you? If this approach is clear, then please like the video and give a +1 in the chat, so that I can move ahead with the further explanation. Okay, shall I move ahead with the second approach for this problem? Shall I move ahead? Okay, so Paramdeer is saying +1. Okay, so I'll move ahead with the next approach. So in the next approach, what I can do is, in the next approach, one thing that you can observe is that again in the next approach, what we can do is, I'll be considering 3 approaches. So this is the second approach. So let us say that the linked list, again we can take the same linked list 5, 6, 7, then again 7, then again 6, and then 5, right? So if this is the linked list that has been given to us, so with this linked list, what we can do with this linked list is, we can reverse this linked list. Okay, this is the original linked list, and what we can do is, we can reverse this linked list. Okay, so in this approach, what we can do is reverse the linked list and store it. Okay, you can reverse the linked list and store it. So once you have reversed the linked list, okay, so John Wick is saying 1 plus 1, so it is 2. 1 plus 1 is 2 or 11. Okay, so reverse the linked list and store it. So if you reverse this linked list, so initially you have been given this linked list, right? That is 5 6. I'll write it again. So what we will do is reverse the linked list and store it. Okay, and store it. So how we'll do this? So for this, what we will do, we will reverse the linked list. So now 5 will be pointing to 6, this 7 will be pointing to this. Now all the arrows will get reversed, right? So the pointers would get reversed. So now earlier what was happening was this 5 was storing this 6, but now you cannot move from this 5 to this 6. Now you can move from this 6 to this 5. So this is how I have reversed the linked list. So I am assuming that you know how to reverse a linked list. Yes, then we will compare both. Okay, yeah, right. So how we will do this? So for this linked list, the head for this linked list is this 5, right? So this is the head of this linked list, and for this linked list, the head is this, right? The head for this linked list is this. So we can move one by one. So what we'll do is we'll move to this 6, then we'll move to this, then we'll move to this, and this 7 for this linked list, then this 7 for this linked list, this 7 for this linked list, then this 6 and this 6 from this linked list, and then we'll move to this 5 and this 5. So since we can see that both the linked lists are equal, then we'll simply return a true, right? Because both the linked lists are true, right? If the if the linked list, original linked list and the reverse linked list both are equal, we'll traverse from the first element, from the head till the end of the linked list for both the linked lists, and if both of them are equal, then in the end we'll simply return true. If in any case, if any node is not equal, so in that case we'll return a false, right? So for this approach, what will be the time complexity? So for this approach, the time that I will take is nothing but order of n, and what will be my space complexity? A space complexity will also be like order of n plus order of n, but it will again be equal to order of n only, right? And space complexity will also be order of n because I'm using a linked list, right? So is this part clear to all of you? If this part is also clear to all of you, then please give a +1 in the chat and please like the video so that I can move ahead with the third approach and final approach for this problem that we are discussing today. Shall I move to the last approach for this problem? Is this part is the first two approaches clear to all of you? If the first two approaches are clear to all of you, then please like the video and please give a +1 in the chat so that we can move ahead with the third approach, right? Shall I move to the third approach with this problem? Shall I move to the third approach? Like Paramdeep, John Wick and all other people, shall I move to the third approach if these two approaches are clear to all of you? Okay, so let us move to the third approach. So in the third approach, what we can do is, can anyone suggest like how we can do for the third approach? So in the third approach, what we will try to do is, basically for the third approach, what I want is, in the third, 1 plus 1 is equal to 2, right? So Ritik Raj, hi Ritik Raj. So in the third approach, what I am basically saying is, let us do one thing, and that is that let us try and implement this in such a way that a time complexity will actually be order of n, because you cannot you cannot do better than this. The time complexity will be order of n because you will be iterating your linked list. But for this, what we can do is we can optimize the space complexity and we can make it as order of 1, right? So we can optimize, we have to check like how we can optimize our space complexity from order of n to order of 1. How we can make the space complexity as order of 1, that is, will not be using any extra space for solving this problem. So now let us say that we have been given the same test case, that is let me draw it again. So let's say we have been given 5 is connected to 6 is connected to 7 to 7 again, then 7 to 6 and 6 to 5. So how we can do this? Can anyone suggest me in the chat if anyone has done this? So can anyone suggest me like how we can do this? So for this, how we can do this? Have you heard about the tortoise method or the fast and the slow pointer method? Fast and slow pointer to find the middle element, right? Have you heard about this concept? So what I'll be doing is I'll be using the fast and the slow pointer, and by using the fast and the slow pointer, what I'll be doing is I'll be finding the middle of the element, and once I have found the middle of the element, so after the middle, what I'll do is, let's suppose that this is our linked list. So what I'll do is, this will be my middle, right? So this will be my middle element. So what I'll do is, this much part, for this much part, I'll reverse the other half. Okay, I'll reverse the other half. So what will happen is, this linked list will look something like this. Let me draw it once again. So what this linked list will look like is nothing but, let me draw it, 5, then 6, then 7. After this, notice that this part, this much part, what I will be doing with this part is I'll be reversing this part. So what I'll do is, now I'll instead of this 7, we'll have this 5, then we'll have this 6, and we'll have this 7. Okay, so I'll be reversing this much part of the linked list. So once I've done with this, so I can check. Now I'll put one pointer here, and I'll put one pointer here, and now I can check that whether this linked list, this new linked list, is this much part from here to here, and from here to here, is this linked list equal or not, right? So is this approach, do you know all? I hope that all of you know like how to use fast and slow pointers. So I'll be telling you like how we can approach. First of all, what we can do for this. So what we'll be doing is, first of all, I'll take a slow pointer, and I'll mark this ahead as a slow. I'll also take the fast pointer, and my fast will also be pointing here. Once I'm done with this, so what will happen? Initially, you know that my fast and slow both were pointing to this pointer, this 5. After this, my slow will move by 1. Okay, my slow will move by 1. Okay, slow will move by 1. Fast will move by 2. Okay, fast will move by 2. So fast will move 2 elements at a time, right? So since my slow is pointing here, so now my fast will be pointing here. Okay, now the slow and the fast pointers position have changed, and now my slow will be pointing here and my fast will be pointing here. After that, what will happen is, now after this, my slow and fast pointer will change again. So what will happen, now my slow pointer will be pointing at this position, and my fast pointer will be pointing at this position, right? After this, you can see that what will happen is, my fast after this, my loop will terminate, and what will happen, I'll be able to find the middle of the linked list, right? So what is the middle of this linked list? For this linked list, my middle is nothing but this, because I hope that you know about the fast and the slow pointer. So you can see that fast next, that is the next of the fast will be pointing to null. So in this way, slow will be the middle of my linked list. So once this is my middle of the linked list, so what I'll do is I'll move my slow from this middle to the next element. Once I have moved my slow here, so what I'll do is, for this much part, that is for 7, 6 and 5, what I'll do is I'll simply reverse the second half. Okay, I will reverse the second half of the linked list. Okay, so how will I do this? So I'm assuming that you know how to reverse a linked list. Even if you don't know, so I'll be showing you the code for that. So what I'll basically do is, instead of pointing from here to here, now this 7 will not point to this 7. What it will do is, now this 7 will start pointing to this 5. Okay, now this 7 will start pointing to this 5, and this 5 will now start pointing to this 6. Once it is done, so this 6 will start pointing to this 7, right? And in this way, my new linked list will look something like this. 5, let me change the color so that it is much more clear and intuitive to all of you. What will happen basically is, 5 will point to this 6, then this 6 will point to this 7, and after this, what will happen? After this, my 5 will point to this 6, and this 6 will point to this 7. Okay, so this is how my linked list will look like. Now notice that at this point, I have my head is here, right? Head was given here, and now my slow is pointing here. Okay, my slow is pointing here. Is this much part clear to all of you? All of you are watching, is this much part clear to all of you? Please tell me about that, and then only I can move ahead. Is this much part clear to all of you? Then only I can consider moving ahead. Is this much part clear to all of you? Like Paramdeep, Ritik Raj, and Ron and John Wick, is this part clear to all of you? Then please like the video and write clear in the comments so that I can move ahead, right? Is this much part clear to all of you? Then I can consider moving ahead. Shall I move ahead? Shall I move ahead? Shall I move ahead? Like Paramdir and others. Okay, this part is clear to all of you. Okay, so now what we can do is now you will check that until and unless your slow is pointing towards the null, so you will keep on iterating. Okay, so you will keep a while loop and you will check that if your slow is not null. Okay, after this what you will do is you will check that if your slow data, if your the data of your head is equal to the data that is stored in your slow pointer, so in that case what you will do is you will make slow is equal to slow next, that is you will move the slow by 1 and you will move your head by 1 as well, right? Head by 1, what does that mean? So basically after that you will move your head here, so your head will now be pointing to this point and now your slow will be pointing to this point. Okay, so head is equal to head next, right? And similarly in this way, since these two are equal as well, so now my head will be pointing to this point and my slow will be pointing to this point, right? You can see that 7 is equal to 7 again, so that is why now after this what will happen is my slow will point to null, right? My slow, after this my slow will be pointing to null. Now since my slow is pointing to null, so I'll terminate, and in this way you can see that all the values were equal. The first half of the linked list and the second half of the linked list, the second half of the linked list which I have reversed is equal. So the first half is equal to the second half, so that simply indicates that my linked list is that my reverse linked list is equal, right? So in this way I can say that my linked list is palindromic in nature, right? So if this was not the case, so in the other part, in the else part, what I'll do is I'll simply return a false, right? Indicating that the linked list is not palindromic in nature, right? Is this much part clear to all of you? Shall I move ahead to the code part? So again, one more thing that I want to tell you is for this approach, the time complexity that I'll take is order of n, because I'll be iterating through the complete linked list, and I'll take a space complexity, and that will be of order of 1, because I am not storing the linked list, or I am not using any array, or I am not making a new linked list. So that is why the space complexity will only be order of n. Now I'll submit my code to show you that it is working, right? First let me submit my code and show you that it is working. After this, like you can see that it has passed in the best time complexity possible. Now let us move to my code and see how actually this code is working. Okay, so let me just zoom in a little bit. So once I've zoomed in, so you can see that what I'll be doing is this is a function that is bool is palindrome. So I've been given this function, I have to complete this function, and in this function I've been passed with the head node. And once I have the head node, so what I'll do is node star fast, that is I'll initialize my fast pointer to the head of the linked list. I'll initialize my slow pointer also to the head of the linked list. And now I've also taken this previous and this null. So let me take this after on. I will talk about this later on. What I've done is I have in this function I have to try and find the linked list's middle element, right? So what I'll do is I'll check that if my fast pointer is not null, and my fast next pointer, the next pointer of my fast, if that is also not null, so in that case my fast will be moving by 2 positions. Okay, fast will move by 2 elements. Okay, and my slow will move by 1 element. Okay, move by 1 element. So once that is done, so once that part is done, so what will happen after this, my slow will be what? My slow will be pointing to the middle element of the linked list. Once I have the slow that is pointing to the middle element of the linked list, so I'll declare a node previous that is null, and I'll also declare a temporary node to reverse the second half of the linked list. So in this much loop, what I'm doing is I'm simply reversing the second half of the linked list, right? I can see a lot of people are watching, so this is the third approach that I am telling you. So if all of you are new who are watching, so please like the video so that it can reach as many people as possible. Now discussing further, so in this part I am reversing the linked list. So what I am doing is I'll check that if the next pointer of the slow, if it is not null, so what I'll do is I'll store the slow next in my temp and after that slow next will be equal to previous, and previous will be equal to slow, slow will be equal to temp. So basically this much part is nothing but reversing a linked list. So what will happen is my 7 was pointing to 7, right? So now my 7 will point to 5, and my 5 will point to 6, and now my 6 will point to 7. So in this way the second half will be 5, 6 and 7, right? And my 7 of the first half will be pointing to 5, right? So 5, 6, 7, and then again 5, and then 6 and 7, then 7, right? So after the reverse of the linked list, the linked list will look something like this. After this, my linked list will point to my slow pointer. I'll need to move my slow pointer to move to the previous element, right? Because I want my slow to point to the middle of the next element of the middle of the linked list. After this, what I'll do, I'll iterate up till until and unless my slow pointer is pointing to the null, and I'll check if my head data, my slow pointer is pointing, slow is pointing to the second half of the linked list. Okay, slow is pointing to second half of linked list. Okay, and my head is pointing to the first half, right? Okay, my slow is pointing to the second half of the linked list, and my fast is pointing to the first half of the linked list. If my slow pointer is not null, then I'll check that if my head is equal to my slow pointer, head data is equal to the slow pointer data. So in that case, I will move both by 1, and I'll keep on checking that whether they are equal. If in case if the head data is not equal to the slow data, so that means the data of the first half is not equal to the second half data for any particular node. So in that case, what will happen, I'll simply return a false. Otherwise, if my complete iteration is done, so in that case what I'll do is I'll simply return true, because in that case my linked list will be palindrome. Okay, in this case my linked list, the given linked list will be palindrome. Otherwise, if I'll return false, then that means that linked list is not palindrome. Okay, so is this much part clear to all of you? Is this much part clear to all of you? Is this much part clear to all of you? Like Paramdeer and Rituraj and Ron, is this part clear to all of you? Then please give a +1 in the chat if this much part is clear to all of you, right? So I hope that this much part is clear to all of you. This was an easy problem. So I'll just wait for a couple of minutes more to see if anyone has got any doubt. If you have any doubts, then please mention in the comments, because I am looking at your doubts. If anyone has doubt any up till now, so you can please mention that in the comments. Otherwise, I want to show you that the problem of the day for tomorrow will be count the number of subarrays. So you can solve this problem. You can see that I have solved this problem. We'll be discussing this problem tomorrow, that is count the number of subarrays. After this, if anyone has got any doubt, like how to check if the linked list is palindrome or not. So Param is saying that the question is clear. What about others? So Ron is also saying that the question is clear. So I can see a lot of people are watching. So please like the video if you like the explanation part, so that it can reach as many people as possible. So I'll wait for 30 seconds more to check if anyone has any doubt. So I can see that up till now no one has any doubt. So in case if anyone has any doubt, so you can tell me. Otherwise, you can write a +1 in the chat finally, so that I know that the question is crystal clear. All the three approaches. First approach was using the array list or the vector to check if the linked list is palindrome or not. Second approach was to make the complete linked list reverse and check with the original linked list whether it was reverse palindrome or not. The third approach was finding the middle element, and after that reversing the second half of the linked list and checking from the first half and the second half if both the parts are equal or not. Okay, please can you give a little dry run to reverse the linked list? Right, reversing a linked list, this is the part. Let me show you how we'll do this. Okay, so let us consider this linked list. I'll show you, no worries. I'll give you a little bit of dry run. Okay, no problem. This is why I was waiting for you. So how do you reverse the linked list? Okay, so in this case what we will be doing is, let me just copy this. Okay, so I have copied the code. What I've done is basically my this is 7, this is 6 and this is 5, right? This is 5 and this is nothing but null, right? This is what has been given to us, right? So in this case, what I'll do is I'll check that my slope, where is my slope pointing to now? Currently my slope is here, okay? So what will happen now? My t will store this 7, okay? This particular 7 will be stored my t in my t, and my slope next, the slope next will be pointing to the previous, right? So my slope next will be pointing to the previous element. What does that mean? Can anyone tell me what does that mean? So basically what that means is my slope next, the next of this slope will be pointing to the previous, that is my slope next is currently pointing to the null element. So that basically means that this 7 that I am currently having, this is my slope next, right? What is my slope next currently? Slope next is currently pointing to this 7, and this 7 will now point to null, right? Because you want to make it to the last, right? So in this way you want it to point to null. After this, what I'll do is, what is my previous element? I'll store my 7. Once I have done that, so what I'll do, I'll update my slope as temp, okay? So now my slope will be nothing but what will be my slope? So in this case my slope will be 7. Now let us move ahead. Like I want to show you further. So what will happen once that it will be null, right? Yeah. After this what will happen is, currently my previous is nothing but this 7, right? Previous is 7, but what will previous is nothing but 7, previous is nothing but 7, right? This is my previous. After this what I'll do is, now my the current data that I'll have is temp is equal to 6, right? In my temp I am storing 6, and what I am doing is, for this 7, for this particular 7, what I am doing is, I have not notice that I have not reversed it up till now. So what I'll do is, simply if I'll perform the operation, so this 7 which is pointing to null, what will happen after this 6 will start pointing to this 7, okay? This 6, notice that this arrangement has gone. Now this 6 will start pointing to this 7. After I'll proceed further, once I'll iterate through it once, so this 6 will start pointing to this 7. After this what will happen, this 5 will start pointing to this 6, okay? And once I'm done with this, so notice that my 5 was pointing to this null. So now what will happen is, what is my slope next? So my slope next is nothing but my previous element, right? And what is my previous element? My previous is 5, right? So that is why I'll store it. And this is how I'll be moving in my linked list, okay? This is how I've reversed this. Also before this, what will happen is, this 7 will start pointing to this 5. So this is how this reversing part is going on. Like you first store in the temp, you will store the next pointer, slow next, and you will update your slow next with the previous, and the previous will be pointing to the slow, and your slow will get updated to temp. So this is how it is working. This is very basic linked list reversal part. You can watch it on the Geeks for Geeks practice channel, okay? So this was the code part. If this part is clear to all of you, then please give a +1 in the chat, so that I know that everything was crystal clear to all of you, right? Perfect. Okay, so everything is clear to all of you. Okay, Paramdeep is saying clear. Okay, so this part is clear to all of you. So thank you everyone for watching, and I'll wait for 30 seconds more. In case if you haven't liked the video, please like the video. And this was it from my side for this video. So please consider subscribing to the channel and like the video as well. Okay. I hope that this question was clear to all of you, right? So thanks a lot. We'll meet tomorrow with the